Hello, welcome to Friends in Tech Automation. We provide practical trainings on PLCs, SCADA, and IoT. Welcome to another episode of PLC programming, and our topic today is internal relays. What are internal relays? Do you know what are internal relays? Do you know why you need internal relays in your program? Now, let's discuss internal relays. First thing, what are internal relays? Just minimize this here. So internal relays in PLCs, they are elements that are used to hold data, i.e. bits. So they are internal relays. I know you understand what is relays, but these are internal relays. So that means that they are found within the PLC. They're just called software relays. They are not real relays, but they behave like actual relays. So in PLCs, they are elements that are used to hold data and behave like relays, being able to be switched on or off. Now, another definition you can use is that internal relays, known as internal coils, memory bits. Like for example, in Siemens PLCs, they are called memory bits. Maybe in Toshiba and Mitsubishi, they are called flags. So internal relays, also known as internal coils, memory bits, flags, are virtual relays inside the PLC. These are just virtual relays inside the PLC that do not correspond to any physical hardware output. That is very important. For example, if you take a look at Siemens PLC hardware and you look at the output section, outputs are like here. If you go to device and networks, just a minute here. Don't want to not to redo things here. Now, if you go to device and networks and we go to device view and select PLC, and let's use magnifier here. I'll just zoom it out. So I'll select device PLC1, and then I can zoom this out. I will take a look at digital outputs. So you find that digital outputs are represented as Q 4.0, Q 2.0. These are addresses of outputs, and also we have QW, that is analog outputs. So they are defined with addresses. That is not true when it comes to internal relays. So internal relays, they don't have any physical hardware address. That must be understood. They don't correspond to any physical hardware output address. So for example, if you want to define an internal relay or a memory bit in your program, you can't define it as I0.1, I0.2. You cannot do that. As well as you cannot define it as Q0.1, Q0.2. So they are used for, underline this here. They are used for internal logic processing, sequencing, and storing immediate states in PLC program. Now, a simple definition you can go with: internal relays are software based. These are software based relays inside the PLC. They are software based, so you cannot walk into a shop and purchase an internal relay. They don't exist as a real world switching devices. Okay, I know you can buy a contactor as a switching device. A relay is a switching device. You can buy thyristor, you can buy triax. Those are switching devices, physical switching devices. But now when talking of internal relays, these are software based relays inside the PLC used to hold or store logic. The good thing, or another thing with internal relays, is just stores bits. It can store 0 or 1. 0 or 1. Now, what are the importance or why are they important? Why do you think internal relays are very important? Now, we have in traditional electrical control panel, relays were hardware components used for logic decisions. And let me just give you an example here. We have this relay circuit. So this was used to control a process, purely relay logic. There's no PLC, nothing, just purely relays. Now, if you take a look at this program here, just a minute. If you take a look at this program, look at it. Down here we have relays. Let me just zoom out, that are doing absolutely okay. I can't say nothing. It was significant back then, but right now it's doing nothing. So we have relay 1, relay 2, relay 3, relay 4, and relay 5. Then these are just indications for cooling complete 4, cooling complete 3. These are useful. Cooling complete 2, cooling complete 1. Now, what are the work of these relays here? Relay number 1. For example, relay number 1, the reason we are having this relay number 1 is to introduce interlock here. This here. You can see this relay number 1 is K1 minus K1. So its contact is used here, minus K1. That's it. Just to introduce an interlock. Just for this here. You're getting me? If you check out relay number 2 here, we are just using this relay number 2 to activate this lamp here, or this pilot indicator. So you can imagine we are just using this relay 2 for this here. Why? Maybe your circuit is 24 volts and this lamp maybe here is 240. So maybe you can use it for that. Or maybe this is the whole system is 240 or 24 or 120 VSC. Still relays are used here. So this here, when temperature is low, this is activated. This relay 2 comes here, does this. So we are just using this relay 2 for this indication, this relay 1 for this indication. So you have to purchase these relays. You're getting my point? You have to purchase these relays. 1, 2, 3, 4, 5. Just for these indications. Just for these indications. Now, what we want to do in TI portal is to remove these physical relays. We just want to enhance flexibility and reduce hardware cost. That is the beauty of having internal relays. All right, good. Now, if you go back here, you're saying that in PLCs now, these relays are simulated internally, saving space and increasing flexibility and even reducing cost. So it is saving space. This is very important actually, saving spaces and increasing flexibility. Now, how internal relays work. So internal relays, you energize set on an internal relay coil in your program. The PLC stores the state in memory. Then the states can be used anywhere else in the logics, just like physical relay. Now, if you go to TI portal here, just reduce this. There. Now, if you come to TI portal here and you go to our previous program, we were discussing about latching. We're discussing about latching here. Now, instead of using motor direct, I want to introduce an internal relay here. Now, instead of using motor direct here, let me introduce an internal relay. So in PLC, actually in Siemens PLC or TI portal, internal relays are denoted using operand identifier M. All right. So when you see M in your program, just know that is a memory bit, or what is called an internal relay. So one thing is that internal relay must be defined in one network and can be used in another network to switch another device. I hope that statement is clear here. So in using an internal relay, it has to be activated on one rank of a program. Then its output is used to switch or operate switching contacts on another rank or ranks of the program. So you're saying to distinguish internal relay outputs from external relay outputs that are given different types of addresses. We say that external relay outputs are given address Q. They start with operand identifier Q. So it can be Q0.0, Q0.1, Q0.2. While internal relays are given address M or MB, all right, memory bit, or just M. Again, this depends with the PLC brand. Now, if you come to TI portal here, we want to set an internal relay so that when you click this start button 1, instead of activating motor direct, it will energize or it will activate an internal relay first. Then that internal relay will be used to switch motor. Now, you can name it anything here. So how do you define this? So you can come to PLC tags, motor tags, and here you can add internal relay, or you can just come here to your program and you can say M 0.0, then that's it. So this is an internal relay. We are calling it tag 1. You can give it a name. I can rename it, rename tag, and let's say motor bit, or let's call it motor tag. That's it. And leave it global memory so that it can be accessed anywhere in the program. Change. So this is an internal relay. So we are saying internal relay, it behaves exactly like an external relay, except that it cannot be used as an external relay. It doesn't provide a hardware output. Now, for example, if I take my CPU to stop mode, then I load the program here, what happens here? That's it, load. And then we go online. You see? So it will behave exactly like an external relay, except that we can't use it outside the program, just outside in hardware. Now, for example, I can take this here, start. See what's happening. So the motor is engaged. I mean, what's not happening here? Okay, I have to remove this here. I have to introduce latch here. This latch also must be motor tag. Must be motor tag. That's it. Good. Then take this to stop mode, then download again. That's it. Load this here. Stop this. Take your CPU to run mode. That's it. So you have it there. So what happens if I click start button 1 like that? So you see motor tag engaged. So motor tag is high. Even after releasing your finger, it will still be high. Now what I will do, I'll introduce this here. So I'll use this internal relay. Its contact normally open down here in network number 2. Then here I'll introduce a motor. So this here is motor. This here is motor. Motor. Then here it's motor tag. It's motor tag. Motor tag. Good. You can do this. Stop this here. Take it to stop mode. Where is it? Can't see you, man. Where are you? Okay, fine. So take it to stop mode, then download this. Load the program. Do this. And do this here. Run mode. That's it. So let's just stop this for a moment. Perfect. So if I click start here, what will happen? What do you think will happen here? So I'll click start. Perfect. So we are using this internal relay to switch a real device, which is motor. So internal relay here is used to switch a real device, which is motor. Now, this is the same networks that we are having here. So we are using these relays, but these are now physical relays. Real relays, relay number 1 to switch another physical device, which is this pilot lamp. So you can imagine if you were to translate this program, this relay logic into ladder logic, that means that physically you'll not need relay 1, relay 2, relay 3, relay 4. You'll have to replace them with an internal relay, something that is software based. So you only need this lamp 1, 2, 3, 4, 5. You only need lamps. You will not need these relays here. Why? Because we are introducing them, we are removing this here and introducing a software based internal relay, which is then used to switch a real device motor 1. Like here, that is the work of these relays here. That's the work of these relays. This relay it does nothing actually. It is used to switch this here. We are using it to switch this here. Its contact is used here. So it's normally closed contact. I don't know if that's normally closed. Let me take it to stop mode. So it's normally closed contact is used to switch this pilot lamp for cooling complete 1. That's the work of this relay number 1. That's also the same work for this relay number 2. Its contacts normally closed is used to switch this lamp here, this pilot lamp. Again, same with relay 3 and relay 4 and so forth. Now, by introducing PLC program, you are removing physical relays, therefore you are minimizing space that hardware will take, and you're increasing flexibility. You are just increasing program flexibility. You're increasing program flexibility. So that's all about internal relays. So internal relays are very important. Then, where can you use internal relays? So internal relays are used still in flip-flops. So we define flip-flops as internal relays still. So our next topic is about, our next video will be about flip-flops, that is set, reset, and RS. So check our previous video, like this video, and subscribe. Thank you.